So this is the, I guess, 1.5 video for notes 20 on the first section, factoring trinomials. In the first video I showed how to do question number 1 and question number 2, but I showed how to do question 3 and 4 using guess and check. In this video, I'm going to do the exact same questions, 3 and 4 only. 1 and 2 are good. You can see the answers right now. But question 3 and question 4 for this video, I'm going to use what's called the AC method, okay, or advanced factoring. So you might be saying to yourself, what on earth is an AC method? Well, mathematicians are not creative about naming things. We tend to name things as descriptive. AC method is descriptive. You are going to take your A value times your C value. So 5 times 6 makes 30. I would like you to find me numbers that multiply to 30 and add up to 17. So I'm just going to start listing out the things that multiply to 30. So 1 times 30. That is not going to make me a 17 no matter what I do. Let's see, 2 times 15. Now that can make me a 17. So here's how AC method works. By the way, I know there are more things that multiply to 30, but once you find the pair that works, you can stop. There's only ever going to be one pair of numbers that works here, so we're done. All right, I'm going to keep the first term the same. I'm going to keep the last term the same. I am going to split the middle term using those two factors. Which one comes first? It doesn't actually matter, especially in this problem where both things are positive. So let's say for giggles, I put plus 2x and then the plus 15x. I'm literally just following the way I wrote them there. That's fine. I think we would all agree 2x plus 15x is 17x. Now, you're probably looking at this going, wait a minute, she took a 3-term polynomial and turned it into a 4-term polynomial. Yes, I did. And here's the reason why. While this full trinomial, right, those 3 terms do not have any GCFs, I can break up this 4-term polynomial and group it. It's called factor by grouping. And we're going to group the first 2, look for a GCF, group the second 2 and look for a GCF. So if I group up the first 2, 5x squared plus 2x, the GCF is x. So I'm going to factor out an x, leaving behind 5x plus 2. Now I want to do the exact same thing for 15x plus 6. Well, what do those have in common? They have a positive 3 in common. The sign is going to be it's going to matter here that we pull that. So plus 3. Now what's left? Well, 5x plus 2. Wait a minute. This parentheses is identical to... Hey, look, that's supposed to happen. So what should happen with your factor by grouping is that when you take out the GCF of the first 2 and you take out the GCF of the second 2, you should be left with identical leftovers, for lack of a better term. These parentheses sets should be and need to be the same thing, because now what you're going to do is factor out the GCF across the entire problem. And the GCF across the entire problem is that identical factor that this part of your problem had and that part of the problem had. So that identical factor, 5x plus 2. All right, and then let's see what's left over. Well, the 5x plus 2 takes out the 5x plus 2. I have an x left. 5x plus 2 will factor out that 5x plus 2, leaving a plus 3 behind. So that would be x plus 3. That looks like a factored form, but here's the deal. If you don't trust me, if you don't trust your own work, if you just don't trust it, let's check it. 5x times x is 5x squared. 2 times 3, 6. Then if I multiply my middle terms, 2x, that becomes 15x, everything's positive. 2x plus 15x makes me a 17x. Folks, I have factored this accurately. All right, this is called a C method. You turn the trinomial into a 4-term polynomial, and then it becomes a matter of factor by grouping. Okay, so this is AC method. I'm going to repeat the process for question number 4 so you see it again. And if you have any questions or concerns, of course, ask. Okay, so moving on over to number 4 here. So AC method. All right, of course, AC method, you're going to take your A value times your C value, and that's going to get me a negative 60. Now, for right now, I'm just going to write out things that multiply to 60. So 1 times 60, 2 times 30, 3 times 20, 4 times 15, 5 times 12, 6 times 10, 7 doesn't work, 8 doesn't work, 9 doesn't work, 10 is already, okay, that's the whole list of things that multiply out to 60. That's a lot of possibilities, okay? But what I'm looking for is a pair of these numbers that, keeping in mind I'm supposed to have a negative, so one of my numbers here is, one of these is negative and the other one's positive. I need to create a 7, specifically a negative 7. So I don't care what you do with the signs for a 1 and a 60. You're not making me a negative 7. 2 and 30, same thing. 3 and 20, I can get 17, but not a 7. 4 and 15, no. 5 and 12, yes. If I make the 5 positive and I make the 12 negative, that will get me the negative 7. So how does this work again? Keep your first term, the 2x squared stays. Keep your last term, the negative 30 stays. Split the middle term using these two factors. Now for this one, does it really matter the order that you write the factors? No. So I'm going to go ahead and write them in the same order. So plus 5x and then minus 12x. So positive 5 minus 12 makes the negative 7. All right, good. Okay, now that you've got the 4 terms, you're going to break it up and you're going to do GCF of the first 2, GCF of the second 2, and then the GCF across the entire problem. So what do the first 2 terms have in common? X. That's it. That's all they've got in common. So 2x plus 5 is left over. Okay, next 2 terms, negative 12x minus 30, they both share a negative, right? Both terms are negative, and they share a 6. So I'm going to factor out a negative 6. So 2x plus 5. Lo and behold, good things happen because that is the same as that. So 2x plus 5 is the exact same thing as the 2x plus 5. So when I look at now finding the overall GCF of the whole problem here, well, that's going to be the 2x plus 5. So 2x plus 5, and then x minus 6. So taking out this, you're left with the x. So that pops there. Taking out this, you're left with the minus 6. Yes, the sign matters. Okay, so double checking against these factors to make sure I get back to the original. 2x times x, 2x squared. 5 times negative 6, negative 30. Multiplying the middle 2, I get 2, I get 5x, positive. Multiplying the outer 2, I get negative 12x. Positive 5x minus 12x is absolutely negative 7x. So those are my factors. And if you were looking at the answer key and or you've watched the other video, folks, you get the same answers whether you factor by grouping or you use guess and check. It doesn't matter. It's the factored form. So the method doesn't matter for these. What's going to matter is that you actually get the right factors. All right, so this is going to be the end of this video. I will pop up a separate video for the rest of Notes 20, which will be a little bit of review on difference of perfect squares. Let me know if you have any questions or concerns on the AC method.